Good morning, Year 10. I'm going to work through this set of slides here. Miss Anderson's been kind enough to develop. As you might have worked out, different teachers are planning different year groups worth of work, and then we as your class teacher are setting it. So Miss Anderson's worked on this for us, and I'm just going to narrate over the work so you get a bit of teaching from me. One of the things I just want to say, I made a little error last week. I meant to ask for you to send in your design work as task 4. I will re-add that onto show my homework as well. So I'd like you just, if you email it to me or just submit it on show my homework, I'd like to then offer some feedback on your designing, so we can improve that ready for when we do the non-examined assessment. So we're going to break up our work into some theory and some prep work for your non-examined assessment. The task we're going to look at today is on energy generation. You will need to either use a piece of paper to write down and complete tasks, or you can use a Word, PowerPoint, whatever you fancy. Okay. Okay, let's move on. If you have any questions, drop me an email. It's paulthompson@kaacademy.org. So, sustainability is one of the first areas we're going to look at. So energy generation is heavily linked to sustainability and how we look after the world around us. So we have covered sustainability in some form or other already, so this is a bit of a recap. So what I'd like you to do, and all of our tasks are in the yellow boxes, is complete the table below. This is our starter. So I'd like you to try and, from memory, work on what the definition for each of these key terms are. And then I'd like you to create a sentence using that keyword in context. So for example, we've got biodegradable here. So paper is an example of a biodegradable material as it is made from an organic material. Therefore, it will break down and decompose. So what's the definition, and then can you use that word in a sentence? Okay, and it should take approximately 10 minutes. Some of you might do it quicker, some might do it slower. The answer for this is at the back of the set of slides here. So at the end of the video, you'll get to see the answer. Okay. Task 2. Okay. You're going to have to copy the diagram below. Okay. So the act of copying was a good one of getting you to remember things. And then you want to add notes onto that diagram, and the next few slides will actually have some more notes that you can add up. So generally speaking, this is how electricity is produced. Okay. So what happens is there is normally water that's boiled that then generates steam. That steam is pressed through a turbine. Okay, so turbine's a key thing here. It's like a set of fan blades, and it spins round really fast. The faster it spins, the more it can turn the generator. The generator is the bit that creates electricity. And if anybody's doing physics, you need to use your fingers like this, Fleming's left and right hand rules, but I'm not going to go into those details now. Okay, so the act of spinning a turbine, okay, will turn some wires inside a magnetic field, which then generates electricity. And to be honest, you can use anything to spin the generator. In this case, most fossil fuels involves burning something to boil water to force that through a pipe to spin a turbine. But you can have a variety of methods of spinning a turbine, and we'll go through that in a bit more detail. Okay. So this is just going through a little bit more detail. Okay. You could read through the details above and add any of those notes onto your slide, onto your diagram that you've created. Okay. Here are a few more notes for you to add onto it. I should be pointing out here at this point that the pink boxes are really useful for getting your keywords. So kinetic energy is movement energy, and turbine, as I said, is the fan blades attached to a big wheel that our rotated speed to then turn a generator. So task 3, okay, reasonably quick task here. I've got a number of images just to try and support it. Can you write a list of what you consider to be renewable energy resources and non-renewable energy resources? Okay, and if you can, think of a definition for what you consider what makes an energy resource renewable, what makes one non-renewable. There's some interesting images there. I like a dinosaur in the top corner. So the next few slides will cover the non-renewable and renewable energy resources. All you need to do here is go back through the work we've already done and add and improve your work. Okay, it's a really useful revision technique, this, particularly if you use a different colour, because it highlights to you which bits you might not know or which bits you might want to look at in a bit more detail. I should add, you should probably pause the slides and pause this video as you see fit. Obviously, there is a PDF of this presentation available to you as well. So nuclear energy, going to be doing a task in a moment about nuclear energy, so you want to take in as much information as you can, and there is a really interesting article that you're going to get to read in a moment about nuclear energy. But it uses the same technique as we showed in the earlier diagram, where water is heated, turned into steam and forced through a turbine. The heat in this case is created through not burning material, but a process of nuclear fission. I could try and go into the detail and remember my A-level physics, but due to the half-life of a radioactive particle, it generates heat, and that then heats up water. You do have to control that with carbon rods that allow slow down the heating process. If those aren't in place, Chernobyl happens, but that's a different story. So here's a task. You're going to read the article below, and I think Miss Anderson has actually got a audio version of this available, which I'll add to the homework. So if you don't want to actually read it, you can actually listen to it. And then there's going to be a task, which is, can you create a table of evidence to suggest whether nuclear power is considered a renewable or non-renewable energy source? There is no right or wrong answer here. This is an argument that scientists are still having. Depending on which way you look at it, you can argue it either way. There's a few key terms in the article. So finite, okay, it's a term that means that something is limited, okay, it will run out. Infinite, infinite, it will never run out. So the resource won't run out. Natural, ongoing process, okay, so that just means that things will grow, things will continue to run. And emissions are, I'm going to say, the gases that release the waste material, as it were, from a process. So nuclear energy, once you've got your tables, okay, so you've created your table of evidence, I'd like you to write a paragraph or two using full sentences to justify your opinion as to whether or not you feel nuclear energy is renewable or non-renewable. We've given you a few sentence starters here, so I would really like you to use the sort of I feel, I think, because at the end of the day, this is about your opinion. I want you to link it to the facts you've got from the article, but you can't be wrong when you're talking about your opinion as long as you justify it. So that's where it's really important that you justify your argument with facts. Okay, and you can argue either way. I have no problem with you arguing either way. I have my own views, okay, but I fully understand they can be considered to be either side of the argument. So just going on to renewable energy resources, this links back to the task a few slides ago. So some of our renewable energy sources, solar, so using solar panels. There's a couple of large solar farms near here, in fact, just to the east of Grove, and also between Hanny and Steventon is another solar farm. So it's quite a nice one to have something quite so big locally. Wind turbines, once again, the wind spins the turbine which generates electricity. Biomass, this is an interesting one because you are burning something here, but you're burning organic material like corn. Willow is used quite a bit because it's quite quick growing. Okay, so you see willow plantations. That gets burnt quite rapidly. Tidal, okay, this is where you can either use the power of waves, or you can actually use the force of the tide going up and down. And then hydroelectric, which is one of my personal favourites. If anybody wants to do a little bit of extended work and reading, find out about Electric Mountain in Snowdonia. I went and visited it. I've visited it a few times now. Really interesting hydroelectric power station that looks after, I'm going to say, protects the country's electricity needs. You need to do a little bit of research there. Particularly important power station for the half-time in the FA Cup final, where everyone turns on their kettles. So task 5 is looking at these renewable sources, in particular solar and wind turbines. What do you think are some of the advantages and disadvantages? You don't have to write anything down here. You can just think about this one. Or you can write a little list if you so wish. But there are advantages of these, but there are clearly some disadvantages, and there's some really good images here that show what might be considered some of the disadvantages, I suppose. Obviously, renewable resources are great. We want to see more of them, but there's also a number of problems associated with them. So have a little think. Pause this if you need to. And I'm going to go on to the next slide, which probably has some answers. Other than the fact that my face currently covers the some of the answers against solar farms, here we have wind turbines and solar. Some of the problems, okay, the cost of setting them up. Okay, they don't produce as much electricity as fossil fuels. For wind turbines, there could be an eyesore. Lots of people go, I'm going to say NIMBY, which is not in my backyard. They don't want them close to them, but they definitely wouldn't want a nuclear power station close to them. So if you had a choice, which one would you pick? Hazard to birds, noise, takes up a lot of land. Surprisingly, wind turbines do take up a lot of land because of you can't do much underneath them or around them. And to put them up requires a lot of space as well. They only work when it's windy. That's very true. So they make more electricity when it's windier, so during winter, which is actually a good thing because that's when we need more electricity. Low maintenance, they don't take much to fix. One of the arguments I always think about here, though, is the amount of steel, big concrete base, which is quite bad for the environment. Where's this coming from, and how much energy does it require to make one wind turbine, and how long does it take that wind turbine to pay for itself, as it were? Similar to solar, one of the issues you've got with solar, it makes more electricity during summer when we need a bit less electricity. In terms of the UK, it's actually sunny right now, but it really wasn't yesterday. Not always a sort of one you can rely on in this country, I suppose. It's clean, low maintenance again, relatively low cost for the energy, but actually the cost of putting solar on your house, for example, is in the thousands of pounds, and it often takes in the region of I'm trying to think now, 10, 15, 20 years to pay for itself. It can be quite expensive. Anyway, I'll move on from here. You can have a read and think of some of the other fors and against there. So this task, a little bit longer. Okay, you can use the following slides, which have got lots of information on, to answer the following questions. So please write out the questions and the answer, or write sort of a paragraph which sort of explains the question and the answer in one. Okay, so I'll go through one question. It's question 2, for example. Which energy source do you think would be most suitable in a coastal area? There's a couple of answers here that you could pick from, I suppose. Obviously, there's an obvious one, but there's some others that you'll see more of if you go to the coast nowadays. So the next few slides have an awful lot of resources. So it's going to look at tidal energy. I wonder which question that could link to. A bit more information about how tidal energy works. I'm going to let you look through the presentation and pick this up. I'm not going to read it all for you at this stage. Okay, so tidal power still, there's a different way of tidal power working. Hydroelectricity, like I said, worth looking at what they call it, Electric Mountain in Snowdonia. Really, really interesting one to look at there. Okay. There's also some more problems with hydroelectricity, I suppose. That was somebody's village beforehand. Oops. Biofuel, some biomass and biofuel. Okay. If you click on those YouTube clips, you can then find out a little bit more information. These are all resources, these slides, for you to actually go through, read, and then answer those questions. And then finally, task 7, I'm going to say, is a bit more of an extension task. Fracking. This is in the news an awful lot, or at least was before we got into the current situation that we're all in. But fracking is quite controversial. There's definitely some links to earthquakes and all sorts going on in the northwest, I think, where we've done some fracking so far in this country. Fracking so far in this country. So worth having a look at this, having a bit of a read. There is some key questions there, okay, about what fossil fuel you'll get from fracking and what harm can be done by the fracking process. And I think I've just answered that slightly anyway. Okay, but the YouTube clip is also there for you. And that continues, okay, into a more detailed one where we want you to argue for and against fracking there. And then it goes back on to a little bit more of the answers as to what fracking is about. And then there's the answers to the task 1, the dirt activity. So that's the end of our video on energy generation for D&T. Hopefully you found that useful. Okay, there's quite a lot of information. There's quite a lot of smaller tasks. Please do get in touch if you have any problems. I actually love it when I get an email asking me questions, because amazingly it can be quite lonely as a teacher when you set work and you just sort of twiddle your thumbs in the hope that someone's doing it. So yeah, feel free, drop me an email if you've got any problems, or a message on Show My Homework. And I look forward to hearing from you and seeing your work soon. Anyway, thank you and goodbye.